So, going deeper with Project Roslyn, exposing the C# and VB's compilers, code analysis. My name is Dustin Campbell. As I mentioned, I put lots of potential points of failure into my talk. Okay, I've got the Windows 8 Consumer Preview. I'm using Visual Studio 11 Beta. I got latest and built this morning. So, being a late afternoon talk, this kind of sets you guys up to enjoy the talk, because at this sort of conference, I know what some of you are thinking. What you really want to do at this conference is kind of snicker and laugh derisively when there's like somebody just spectacularly fails up here. So I've set it up for you guys so we can have a lot of fun. At the end of the day, you guys can enjoy yourselves, and hopefully I'll crash spectacularly for you because I've introduced these points of failures. But we're going to talk about Roslyn. Let me first kind of set this up by talking about what Roslyn is, and then we're going to talk about kind of what Roslyn is not, okay? Because there's a lot of theories kind of floating around out there, and I've talked with some people that have had different ideas about what Roslyn is that may not have been exactly precise. So, as Anders mentioned yesterday, Roslyn is the compiler rewrite in managed code for C# and the Visual Basic compilers. So, rebuilding the C# compiler in C#, rebuilding the VB compiler in VB, and having a bunch of shared code in between that's in C#. Now, that's just a piece of Roslyn. That's at the very, very heart of what we're doing, but really we're building the entire language experience, including all of the tooling. I work on the Roslyn language services, and when I say a language service, I mean all of those kind of tooling experiences, things like statement completion and all the extra editing capabilities for a language that we build on top. We're also rebuilding all of that in C# and in Visual Basic. Okay? We're building code analysis APIs on top of the compilers, and then using those APIs, we're building that tooling on top. Okay, so the APIs are rich enough to build our rich tooling experiences. In addition, we're providing extensibility for the language service features themselves, features that have typically been black boxes before. I know there's a few in here. How many have tried to write a Visual Studio extension in here? Yeah. So when you actually try and start mucking with the C# language service or VB language service, try and insert things into IntelliSense, you quickly run into barriers. So we're introducing extensibility points into those language service features as well to allow you to extend them in a more kind of supported and official way. As part of this, we're also building a readout marching boldly into the 60s. But this is something that with these APIs, we're able to dynamically compile and execute code. And by building this window, it gives you kind of a productivity boost in C# and VB that you haven't had in the past. The ability to kind of explore APIs, play with code, build up some context, and kind of build up applications in a different sort of way than just kind of the compile debug cycle. Now the ship date, which is somewhat, there's some contention here, but I will say that we have shipped. Okay, we shipped an October CTP that was public, and it's available right now. It's on msdn.com/Roslyn. And then other than that, I've put a function up here. We are shipping in vnext plus n, where n is greater than 0. Okay, so extrapolate that as you will. It means we are not in Visual Studio 11. It's not shipping Roslyn. Some future point, Roslyn will have a final release date. Now, what Roslyn is not, I didn't put this on the slide, but I do want to speak to it based on some conversations I've had. Roslyn is not a compiler framework for building your own compilers. So there's been some questions asked about that. That's not what we're building, partly because we want to complete this project. And to build a compiler framework, to build some one uniform type scheme to rule them all kind of thing, usually ends in not shipping. And so we want to ship, and so we've scoped the project, really, kind of scoped what we want to work on, been very, very specific about being about C# and Visual Basic. Okay? Another question I want to just kind of talk about right up front was what about my language and language X? And again, that's a scoping thing for V1. Really, it's about C# and Visual Basic and getting those done and out there. All right, so let's demo. You guys, I mean, as I said, it's much more than the compilers. It goes all the way up the stack. In fact, a lot of what we're doing is about getting up higher in the stack to some of the things up in the IDE experiences. So let me show you a little bit here, what you can do. So I'm loading Visual Studio 11. I have the Roslyn language service loaded in this instance of Visual Studio 11. Okay, and so what that means is that everything you see right now is completely done again. Okay, so the the outlining, the syntax highlighting, everything here is completely new. In fact, you can tell that it's Roslyn because right here it says so, right? Okay. But this is all brand new. You'll see kind of things kind of come up there a little bit different if you're familiar with the existing C# Visual Studio experience. I'm just going to kind of show you some of the things you can kind of do with Roslyn that may not look great on a smaller screen resolution, but that's okay. So the idea here that I can do some refactoring very quickly in the editor. All I did was select some code, press Control Dot, choose Introduce Local for replacing all, and immediately that's been done for me, and I've placed it in inline rename experience. I can make my change, press Enter, and I'm done. Okay? Let's do that again down here. Do the same thing. Again, I apologize for this kind of prototype UX that's showing up here. Remember, we're the compiler guys. We're not the UX team. Okay? So I apologize for that. But that is prototype work. All right? Now, I'm looking at this code right here, and I see that circle area is just, it's a calculation of a circle area, right? We should extract this to its own method. We should be good refactoring citizens. We should promote code reuse, right? So I'm going to bring this up, and look, it gives me a preview. Look very carefully at that preview. What's it going to name the new method? And this is where Roslyn's really powerful because we're statically analyzing this code, determining that it's the formula for calculating a circle area. No. No, that's not lost on you guys. No, it's just simple heuristics, right? So this expression is assigned to a variable called circle area. Let's give the method a reasonable name. Call it get circle area. Okay, so I don't even have to do it in a rename at this point. I'm done. Now this is just used the one time, so I'll go ahead and inline that. And again, I'm just shaping my code very quickly using a couple of keyboard shortcuts, picking my names, moving around. Now this is kind of what the promise of some of the things we can do with Roslyn, because we have these code analysis APIs, we can build these brand new experiences and move very quickly. Those previews happen because we have the code analysis there, we have the infrastructure, that sort of thing. Now, what I find especially cool about this, as I said, we're building a REPL, we're going into the 1960s and all of that. But that REPL is far from a 1960s REPL, okay? I can do 1 plus 1, so yes, the high working set calculator joke, insert here. But I can also do some other things, right? I could paste that code. You see full colorization, right? We'll give this a different name. And I come in and I can do the same stuff I just did in the REPL. Right? So we can say introduce local, do the same sort of inline rename, come around, get the circle area. Oops. Right? And I can execute that in the REPL. What's great now is I can do all of my kind of the editing experience that I'm comfortable with, the power that I use in the editor, and I can just do it down here as well. Now I've got IntelliSense, and I could call get the circle area or whatever. But all of that IDE experience works in the REPL as well. And that kind of comes out of the architecture we've built. I'm going to share it with you, but I just kind of want to give you a taste of where we're getting to. Okay? Let me actually shut down that instance of Visual Studio so I'm ready for the next one. Yeah. Okay. So let's talk a little bit about the APIs. Now, I'm going to show this slide. We've shown it a number of times, but I know not everybody here is familiar with it. As we rebuild the compiler, we rebuild the entire compiler pipeline, the various components of the compiler, we build API on top of that. Okay, so on top of the parser, there's a syntax tree API. On top of symbol table, metadata import, there's a symbol API. On top of the binder, right, there's going to be a binding API, flow analysis APIs, and then a small mid API on top of the IL emitter. And as we build that public API surface, we're building out the language service features that would go along with those APIs. So as syntax trees come on from the parser, we'll start working on things like code formatting or syntax highlighting. But as you can see, we're literally building everything again. And what's great about this is that it's all on top of public APIs. So if we can build edit and continue on top of the emit API, certainly, it's powerful enough to do some really cool stuff with. All right, now let's get down into some kind of detail on the layers and how this is organized. So this is the compiler pipeline API we just looked at, okay, and I just kind of did really clever animations over top of. This represents the compiler sort of API, and I want to mention one thing here, that there are actually two of these APIs. There's one per compiler, okay? The APIs are full fidelity for the language that they target. Again, like I said, we're not trying to solve the one tree to rule them all sort of problem. So they are high fidelity. They look the same. They use the same patterns. They look very, very, very similar. Properties are the same. But there are two, essentially, copies of this API, the compiler layer. Also at the compiler layer is a set of scripting APIs. So if I want to execute code on the fly, if I want to compile code to a delegate, get it back, hook it up to a button, click event handler in my application, I can do that sort of thing with APIs from the compiler layer. Now on top of the compiler layer is what we call the services layer. We are not very good with the clever names, okay? So services layer, being as vague as possible. But the key part of this layer that which is kind of where things start coming together, is what we call the workspace API. The workspace is kind of what manages the bigger picture. All right, it kind of does a bunch of the heavy lifting of the fundamental components that are in the compiler API. So I could take the compiler API and I could wire up compilations and parse trees and stick things together, or I could go to the workspace API and ask it to just load a project or load a solution and do those things for me. Okay. Also, what happens in the workspace API is sort of that those high fidelity separate compiler APIs and the symbols and things that come out of that sort of become kind of a unified view within the workspace API. So if I load up a solution that has C# and Visual Basic projects in it, it looks the same to me as an API consumer. And I can call services that are built on top of the workspace API with one entry point, and depending on whether that's on C# or VB may operate differently. So I can call find all references on a symbol. It'll find references across C# and Visual Basic. Doesn't matter which symbol I call it from. I can run the code formatter, and it's going to work with the proper rules for either C# or Visual Basic, depending on what tree or what node I operated on. Now, on top of the services layer is what we call our editor services layer. And so at this point, everything below this layer is essentially free of anything UI related. There is no editor, there is no Visual Studio or anything like that. And so everything below this top layer can be used from within any application, really. It could be used from within a console app if you like, or anything whatsoever. Now this depends on the Visual Studio editor. So this is a very key layer for Visual Studio. And this is kind of where our IDE features live, where the statement completion and the signature help and all those features live. They're built on top of the workspace API, but that's where they live. And there are extensibility points built into this layer to extend basic, kind of some of the IDE features. So code actions, which is something for, it's kind of the API we use for doing refactorings and quick fixes and those sorts of features, lives in the editor services layer. Classification, which is colorization, so you can extend colorization. If you want to color your fields purple, you can do that pretty easily. Okay? Now, some of the design characteristics of these APIs, and this kind of goes from the very bottom all the way up to the top, and we get a lot of mileage out of these. So, first of all, things are immutable. Everything's immutable. Logically immutable, I might add, as Neil and I were talking about at lunch today. But conceptually, when you get objects from the Roslyn APIs, they cannot be changed. Instead, you make changes to them, they come back as a new instance or a new snapshot of that object, right? So if I parse a syntax tree, that can't be changed. I get a lot of mileage out of that because I can take that tree and pass it around asynchronously, around multiple threads, whatever I want to do, and I don't have to worry about taking lots or anything like that. And we take great advantage of that in the IDE. Complete. This characteristics is important because we really want to use this compiler API and all the code analysis APIs to really build a next generation experience. And so we need full, complete trees. We need white space. We need comments, everything represented in there. Errors should be represented in the tree, hanging off the nodes where they're at as actual objects in the tree. Yeah, so we need absolute completeness, and that carries through the API as well. And what that kind of gives you, actually, that gives you some really nice sort of features, like if I parse a tree, I make some changes, I transform it, and I want to get the source code, I just call toString and get it back. Okay. Resilient, meaning having fault tolerance to errors, and there's a strong notion of fault tolerance in here because if we're building IDE features like statement completion, we need to be really fault tolerant because statement completion is almost always on broken code. Right? If I type a dot and statement completion comes up, it's not going to compile. Right? And so there's a very strong notion of fault tolerance. Again, that goes also with the same sense that if I parse a piece of error text, just broken code, and I parse it into a tree with errors, call toString on that, I still get back the same source code with errors. And then finally, it's efficient. So we're very efficient at building up snapshots. There's an incremental parser. We share nodes across snapshots, all that good stuff that you guys are familiar with. And we're generally very, very, very efficient. Okay, so let's take a look at some of the major players. So kind of laid some of the layers out, look at some of the design characteristics. Let's look at some of the major API players. So first of all, obviously, there's syntax nodes. And these are kind of the non-terminals, right? You parse a tree, and then you get a strongly typed view of the various nodes within that tree. So up in the top right corner is a piece of C# code, or almost Java code. And there's the non-terminals that would parse into. Now also, you can see that we also will parse tokens. So you can decide whether you want to look at this in kind of a node view, or if you want to just walk the token stream, you can do that as well. And then here's where it becomes a little bit gnarly. So this is the syntax trivia bit. So every token in the tree can have leading and or trailing trivia associated with it. So as I'm walking the token stream, I'm not walking over white space and comments or other things that can go between tokens like preprocessor directives. But instead, I can ask each token individually, do you have leading or trailing trivia, and deal with that if I need to. This always brings up kind of the joke that there's nothing trivial about trivia, and it's absolutely true. And when we start playing with some code a little bit later, you see that it can often become kind of fiddly to start playing around with trivia and making it do the right things. But this is kind of the view that we have, and it's the more complex view, rather. So that's great for syntax. If I want to move into asking semantic questions, I need to build up a compilation. Okay, a compilation is kind of analogous to, say, an instance of the C# or the VB compiler, where I've passed in references, I've passed in some files, and that's kind of what you get. So if I take syntax trees and references, add them to a compilation, at that point, I've got access to symbols. I can go to the global namespace and start walking through all the symbols that have been imported into this compilation, or a part of this compilation as part of the trees. I can omit, I can do all sorts of things, but I can, most importantly, if I want to do analysis for any tree that is contained inside that compilation, I can ask for its semantic model. And from the semantic model, now I can start asking questions. So this, just to answer the question that will eventually come up at the end of this talk, no, we do not expose what is, traditionally a bound tree. Instead, we've taken the approach of providing a binding API that you can ask questions. That's the semantic model. So I can ask questions of nodes in a tree that's in the compilation. I can ask, what is the symbol that some expression binds to? But you don't get to walk a bound tree, per se. So you can ask all these various different kinds of questions about overload resolution, conversion classification, all sorts of interesting stuff off the semantic model. All right. So this is the one that's a little bit trickier. We've looked at kind of just walked very quickly, very breezed through the compiler APIs. Above that is this services layer with the workspace API that takes these kind of foundational components, as I said, from the compiler layer and really starts to unify them into a view that kind of makes it much easier to work at a larger scale. So you can imagine that if I had several projects and I wanted to plug them together, I'd be creating compilations. I'd be creating compilations, trying to plug them together, parsing MS build files to get the compiler properties that I want to put on the compilation. So that's a lot of work, right? And so instead we provide this workspace API, which has an object model around what in Visual Studio are solutions, projects, and documents. Okay? Now, under the hood, those really are compilations and syntax trees that are lazily populated as needed by the workspace. So if I go to a document and I say, give me your semantic model for this document, well, it needs to go to its project. Say, do I have my compilation reified at this point? If not, it'll reify it for it. And are there other compilation references that need to be realized as well? And it'll go off and do all that work lazily, which gives us scale. Okay, so in some experiments, we've been able to kind of get this, loaded up with about 5,000 projects and still see the IDE features working. So this model gives us the scale we need. Now, the solution, just like everything else, this is an immutable snapshot model. So if you don't want to just kind of work with this immutable model, you want to have some version of the truth out there. Like, what's the one true solution that's actually alive right now? And the object that manages that we call the workspace. Okay? And that's kind of where this one true solution lives. And if you want to, say, take the solution, you can go to the workspace, say, give me the current solution that's out there right now. Let me make some edits to it. I can fork that solution, go off and do everything I want to do, come back to the workspace and say, you know what, I'm done, let's apply. Okay? And so by performing these transformations and then applying them to the workspace, you can actually do this. You can have several features going out there where I just, and doing transformations, forking the same solution, building their own forks, come back and say, oh, well, the user picked this one, so we'll apply that to the workspace. Okay, so when I showed that smart tag with the various refactorings that were available, each of those was doing a computation in the background, you know, forking a solution and coming back and saying, here's the result. This is what this refactoring would look like. And then we're able to show preview and all that. So the workspace itself lives in a host environment. So the host environment is responsible for moving that workspace along. So as key presses and various events come into the host, so think of the host as Visual Studio or whatever. As you know, there's key presses. It's going to go ahead and it's going to run the incremental parser and make sure that the current solution attached to that workspace is up to date. Now, what's great about this model is that the host environment doesn't just have to have one workspace. If our IDE features work on solutions and documents and projects, really they can live anywhere that there's a solution, project, and document. And so that's how we make our features work in the REPL, in the interactive window. There are two workspaces when I have the Roslyn language service loaded. There's one that is keeping the current solution of the currently loaded Visual Studio solution, and then there is a workspace that represents the interactive window, and the projects are represented, the submissions are represented as a chain of projects. And so IntelliSense just works. Statement completion just works. All right. Demo. This is a short talk. It feels like a lightning talk because it's just a short amount of time to get this stuff done. So I want to build a quick fix with you guys. I want to build something that effectively the idea here is that I want to take I want to analyze a tree. I want to analyze local variables and determine whether they can be converted to local constants. Okay. So the first thing we'll do is we'll actually squiggle those in the editor. Just give them a little green squiggle and say, hey, this could be a constant. And then we'll go back and we'll write a code action for that, which actually performs the transformation, returns it, and shows preview and does all of that goodness. Okay. So I'm going to create a new project. We're going to call it make const. I'm creating a code issue project. This is, I have the Roslyn CTP installed. This is the Roslyn projects. Okay, so here's kind of the basic boilerplate we get. This is a code issue provider, which is something that plugs into the system and serves up code issues, which are essentially a code issue is an interesting span in my code for some reason, however your analysis wanted to make it. So this has some really trivial boilerplate code in here. It really just says, it takes for every node in the tree, it grabs all the tokens, it iterates through them, says what tokens contain the letter A, and if they contain the letter A, it creates a code issue that says, hey, you contain the letter A. It's kind of ridiculous, but it serves a purpose. So I'm going to build and control F5, another potential point of failure, because I got to incur, oh, nope, it's up. And so we should see here, now we have Roslyn language service. Again, and we can see that, yes, these contain the letter A. Okay? It's exciting. It's exciting. We have made history here. Now, I'm going to go ahead and modify this to do this sort of conversion analysis to detect a local variable that could become a local constant. And the way this is exposed right now is exposed through MEF, the Managed Extensibility Framework, with this export attribute. And the way it's exported right now, it actually runs on everything in the tree. So every node in the tree, it gets run on. So I would like to restrict that for local variables. It seems a little overzealous. And so in my export, I can tell it to just focus on local declaration statement syntax. I can give it a type of syntax node that I'm interested in. Okay? And now we can get rid of this ridiculous boilerplate code. And the first thing I can do here is I can actually just cast the node that came into a local declaration statement syntax. I declared in my export, that's what's going to be, that's what I care about, and so I can just assume that's what's coming in. Now, who can tell me what the first thing I should do in my analysis is? If I want to check to see if a local variable can be made a local constant, what should be the first thing I do? Yes, sir?
See if any code changes it.
It would be a good thing to do, but that's not necessarily the first thing. We will do that. We need to make sure that nothing is like it's not written anywhere, right? What else? That's very good. And we can do that syntactically. We need to make sure that it's not already a constant. Okay? And so I can do that by going to the local declaration, to its modifiers property, and make sure, see if any of them are the const keyword. Okay? If there are, then we're just going to bail, we exit. Okay, next, and this is in C#, if I'm going to declare a local constant, all of the variables in that declaration need to have initializers, and they need to be constants, right? And so we'll do that check next. But to do that, we're going to have to go to our document. Now, a document was passed in here, and we can say, give me the semantic model. And again, this is this kind of transparent API that may do more work behind the scenes, or it may not, depending on how much of the solution is realized at this point. But this gives me this model that I can now go and ask semantic questions about the tree that is inside this document. Okay, so we're going to check this bit of code. We loop over all of the variables in the declaration. Remember, there could be more than one, right? It could be int, x comma y. We make sure that they have initializers, and then we ask the semantic model right here. Say, give me the constant value of the initializer's expression, essentially its value. If it doesn't have a value, then we're done. We bail. Okay? Now back to your question, which is the more interesting one. We need to perform data flow analysis. We need to make sure that these variables are not written anywhere else, right? Otherwise, they can't be const. That would be an error. And so we're going to perform data flow analysis. And that's done very simply. Go to semantic model and say analyze statement data flow. We pass in our local declaration syntax. Now, the way this object that comes back to us is it's actually a set of properties that are collections of symbols in various states, right? So, we can see which symbols, flow in or flow out, what are red inside, red outside, all sorts of things. What I really care about, because I'm running this on the local declaration statement, I want to make sure that it's only written inside the local declaration statement. So I'm going to check each of these variables and make sure that they're not included in the written outside of this statement. Okay? And so right here, I loop through all the variables. We go to semantic model for each variable. We say, give me your local variable symbol, and then the data flow analysis written outside collection. If that contains any of our variable symbols, we're done. We bail. And then finally, now that we've done our analysis, we return our code issue with the local declaration as the span. So to prove to you again that we are running on real code, I'm just going to run, bring up the same demo fodder solution, and we should see some squiggles, unless I've done something wrong. There we go. So these guys can be made const. Okay, they can be made into local constants. Now if I come in here and I start typing, remember there's this hosted environment is driving this workspace, right, forward by key presses. So if I start typing, then things just go away. My code issue is run, and that no longer qualifies. Okay? If I type here, well, then the next one's because those two are now local constants. Okay? So you can see how this model kind of just goes, just gives you a lot for free. All right. Now that's great. We've been analyzed. Andrew Kennedy, you have a question, sir? Does the data flow pick up if the variable is passed by reference elsewhere? Yes. Yes. I repeated the question successfully, Don. Okay, so now that we've got this analyzed, we know we have our local variables that can be made into local constants. Let's write a quick fix to do that. Okay? So to do that, I'm going to write an accompanying code action. I'm just going to add a file to this project. We're going to call it code action. And I'm going to add a couple of namespace usings up here just to get us started. And we implement a code action by implementing an interface called iCodeAction. Oops, and I need to type the correct one. And that simply has a description, icon, these are the things that would show up in the smart tag, and then a getEdit method. And that's where we're going to do our transformation. Now, to do the transformation, we're going to need some pieces of information from my code issue provider, right? So I'm going to come back here, and from the code issue that I've returned from this getIssues method, I can also optionally offer an array of iCode actions. So I'm going to return an instance of the code action we're creating. I'm going to use Visual Studio features. You can use these in clips as well. But to just kind of call a hypothetical constructor with the information that I want, I need to pass the local declaration in. I need to pass in the document so that I can perform the transformation. And in the current version of the API, there is an iCode action edit factory that's used to help build these iCode action edits. I'm going to pass that along as well. Hopefully we can get away from that in the API in the near future. It's kind of a wart. All right, and I'm going to press Control Dot to use Visual Studio's generate constructor just to get that data in there for me. So now I've got a constructor, I've got fields, I've got them all initialized. I can go ahead and write my logic. Now the first piece is going to be kind of fiddly. Remember I said before, there's nothing trivial about trivia, and I want to be careful with trivia here because, for example, I could have code that looks like this, and there's a comment in front of that. So I need to, what I would really like to be able to do is to insert my const token in front of that comment, right? But to do that, I need to kind of strip the trivia off the first token of the statement, kind of stash it somewhere, and when I create my const token that I'm going to insert into the tree, I need to put the leading trivia on attach it to the front of that. So, whoops, that's the wrong one. There we go. And that's exactly what we're going to do. So the first statement, first line of code grabs the first token of the local declaration. The second line just takes the leading trivia and stashes it away. Or this is all immutable, right? So I can stash it away and not worry about it going away. I'm going to take the local declaration. I'm going to replace the first token with a version of the first token whose leading trivia has been replaced with an empty trivia list. Okay, so it's a little fiddly. And then finally, I'll create my const token with the leading trivia that I'd stashed away. So essentially just taking the comment off, stick it on the front. This is the most fiddly part of it, I promise. Okay. So next, I'm going to create a new modifier list for my local variable, and it's just going to the local declaration, or to the trim declaration I just created, to its modifiers property, insert at index 0 my const token, I get back a new modifier list. Then I can create my new local. So again, I can go to the trim local, the one that has the trimmed first token, call with modifiers, passing new modifiers, and get back a new local variable declaration. Now here's something that's a little interesting. I want to format this using the appropriate code formatting rules for C# or Visual Basic. And so I'm going to attach what we call a syntax annotation. I didn't describe this. It's kind of a feature that's, it's not one of the primary players, so I didn't mention it before, but you can add annotations to nodes that represent kind of some custom data that then participate as part of that node's identity. They become part of that node's identity. And so I'm going to add a well-known annotation we use in the code actions engine for a formatting engine that says, hey, run the code formatter on any nodes that are annotated with this annotation so that we get things formatted properly at the end. Now finally, these last steps, I go to my document, I ask for its syntax root, the root of its tree, and then taking that root, I replace the old local declaration with the new one, the newly formatted one, getting back a new root, and then finally I go to that edit factory, called create document edit, pass in a document, and I pass in a document with its syntax root updated. Again, all immutable, right? So we're getting back, so we're calling things and getting back new snapshots. We'll control F5. And I pray that this works. It works. Okay? So it inserts const. Well, now what I love about this, and this is kind of the payoff, check out what's happening in the preview window. The code issue we wrote is running inside the preview window as well. It's like a window into the future. Like Doctor Who has come and kissed and blessed our code issue, and it's just, it's working marvelously for us. So there's actually a little workspace running inside that preview window. And so that kind of snapshot of the universe that we create, and when we create those transformations, our features can run in there as well. We can say which features we want to run. We're not going to start putting smart tags in there or anything. But we can get a lot of mileage out of this. All right, so there's a couple of bugs. I know, it should be bug-free, right? There are a couple of bugs that we should fix. So first, this should not be made a constant. Peter Hallam knows why, I'm sure. But you can't make a string literal a constant unless it's actually a string, right? So this is illegal, and you can see that because it actually squiggles red in here that this is a bad thing to do. And there's one other thing that's very, very foul. I can't believe I did this. But it doesn't handle var at all. So it just says, let's make a const var, which is illegal in C#. Okay. Those are easy to fix. Okay, so we're going to go back to our code issue provider. First, we're going to handle this special case for the string. Okay, and I'm going to do that in the code where we check the initializers, we check the constant values of those initializers. We can also come in here as part of this and check our special case. We'll say, if the constant value is a string, then we'll go and check the type of that variable declaration. If it's not a string, if it's not actually this special string that we care about in C#, which could be any core lib out there, then we don't do anything. We can't create that. So, and last, we'll go to our code action and we'll handle var. So I'm going to, instead of just producing my new local variable declaration here, we're going to do a little bit more magic. We're going to check the type of the variable declaration, make sure if it's var, then we're going to actually insert the real type name, okay, instead of var. So first I grab the variable declaration, I check to say, is the type syntactically, is it var? Okay, and that's not enough. Eric Lippert informs me this is not enough. We need to go to the document, ask for its semantic model, get the type info, get its converted type for that for the variable declarations type, ensure that its name is also not var, because var is a contextual keyword in C#. We need to make sure it doesn't bind to something crazy. Do not go around creating types with lowercase var as the name, okay? Don't do that. But if you do, we will solve for that. All right? Now we're going to take that type, we're going to get its display string, which will be its fully qualified name, so with namespaces and everything. We're going to parse it using the parser context to parse a type name. And we're going to attach to it the leading trivia and the trailing trivia from the original variable declarations type. I'm just going to keep going fast because Mads tells me I'm almost out of time. We're going to add a name simplification annotation to it, which is another one of these well-known annotations that says, hey, Code Actions Engine, make sure to simplify this name in its current context, taking into account using directives, namespace aliases, and whatever. And then finally, I hope finally, we'll go ahead and we'll replace the type in that variable declaration with a simplified name. Control F5, see Visual Studio come up. And bam, look at that. I'm a genius, it's great. I was using snippets, right? And yes, this works correctly. So that's kind of a taste of how you can use Roslyn to extend the IDE experiences. Let's just flip back the slides very quickly. Some next steps for you guys. If you haven't checked it out, try the CTP. It's a little dated. I'm not going to lie. We've made a lot of API changes since then, taken a lot of feedback. But that came out back in October. So please try them out. Give us feedback on those APIs if you're interested. The links are up here. There's a Dev Center link for msdn.com/Roslyn, which is where you can go get it. There's a forum link, and there's my email address. So I think we have time for questions, but I actually don't think we have time for questions, but I'm the last talk, so I think I can take questions.
So thanks a lot. We all really appreciated that. That was very interesting. So I suspect that there will be a lot of questions. So
or not. Everybody's
or
really
not.
tired.
Everyone wants to leave.
It's actually the entire Roslyn team. That's all that's out there.
No, but I'm not going to let them ask questions.
Are there any questions?
So it must be easy to screw up, like create a cycle in a syntax tree or something like that. Does it just crash and burn? I mean, what happens if you mess up in your...
Well, don't do that. I mean, I just,
Well, I would
it's not
imagine
it's like
a
you really have to
plugin
go out of your way to do that.
Right?
Yeah.
To your ID. I mean, Eclipse plugins have that issue too.
What's that? Yeah. I'm not sure how you would make a cycle, actually. Everything is immutable. So it would be very difficult to make a cycle, I think.
So the plugins that you're writing are executing in the space of the IDE, or is it in the space of the compiler? Like what where is the code that you're writing executing, and where are the types that you're referencing bound? I guess in the spirit of Martin's talk yesterday, the types that you're bound to, that you're comparing against, all that. How do you maintain the hegemonity between, or the hygiene between all those environments? And how many environments are there?
So how many environments are there? Well, to date, I mean, as far as you mean the hosted environments where we do this kind of work right now?
There's the compile time environment where your plugin gets compiled, and then how many environments are there at runtime? Is the environment in which your code is executing completely separate?
It's in the IDE.
Okay.
Okay. So right now, the Roslyn compiler is a set of libraries right now, and you literally the extensions are loading those libraries and performing analysis with them. Okay. And there is the Roslyn language service also loads the compiler up. That workspace host is continually running an in-process compiler version of the compiler to pull the compilations forward. Any other questions?
A question about the trivia that is attached to the nodes. I'm not sure if you can answer this question. So when you reformat all the stuff, then some of the trivia, particularly comments, they move around like crazy. And I don't know what your formatter does. Does it try to do anything fancy to make it?
It does. It does try to do fancy things. It's very, very fancy. The one in Visual Studio 2010 is very fancy, and we need to reach have the same kind of fanciness. So yes, it's very fancy, and really our formatter is really about manipulating trivia and manipulating white space, and so it does a lot of just kind of going through the nodes and going through the token stream and munging those all up until it's looking great. The actual formatting engine is also extensible. There's a rules engine there, so you could add formatting rules and do custom stuff if you want to as well. Is Roslyn up for developing itself?
That's right.
You mean, are we dogfooding and self-host right now?
That's right.
Not yet. Part of that is that it's a very big language to both of them, very big languages to go and implement, re-implement. And so we're not quite at the state where we feel like we're at a place where we could be productive dogfooding. We are very focused on performance and typing responsive and all those things, so that when we do get to dogfooding, it's not absolute torture. But we're not dogfooding yet, simply because the language support is still getting fully baked.
All right, time for one more question. Who was first?
And I'll be going out afterwards. If anybody's going out, we can talk and chat.
So how extensible is like things like the grammar? Can I add new productions and new parsing?
That is one of the things I forgot to mention in the what Roslyn isn't. So yes, Roslyn is not about adding new keywords to C#. You could probably do some hackery to make something sort of look like that, but it's not a goal of Roslyn to allow you to modify the grammar, modify the C# language or the VB language. There's some good reasons for doing that. One, we'd like to rev the language, continue to in the future, and so it's having all these offshoot versions might make that kind of difficult. But also, it's part of the scoping of a V1, right? We want to get this thing out there and get this thing done, and some of those sorts of scenarios just kind of fell below the bar. Okay.
All right, let's take one more really quick question.
When you guys were implementing what you have so far, did you discover any really strange corner cases in the existing C# compiler, or?
No, it is. Mads has developed a beautiful spec that is complete and perfect. Yes, we found all sorts of things, and we continue to find things, and we're trying very hard to replicate that behavior of the old native compiler, not necessarily including unspecified behaviors.